All right, let's get cooking. Well, yeah. Once we get to bubble sort, bring it up, and we'll watch it. We'll be. I mean, is it like class appropriate? Well, it'll make sense once we get to it. So everybody focus. All right. So focus on me. Don't focus on everybody on this laptop. All right, everybody online can hear me fine?
Yeah.
All right, so let's get cooking here. So the assignment for this last class was to create your Bible book, expand your Bible book program to have the to read in the information from a file, right? So that should have been fairly straightforward based on what we did in class last time. So if we go to our input.dat file, I'm just going to steal these couple of lines here. And what did I say they were surrounded by? Colons? All right, so I'll put that on line 1 there. Put this on line 2. And then line 3. All right, so I have 3 different Bible books I put in there. I think you were supposed to do it for the whole New Testament, whatever. So I'll just do it for these 3 quickly. So then the idea is maybe for your Bible book, you add a constructor. So we'll add another constructor in our Bible book. Just steal this guy. And this guy takes in a string. And he'll, maybe we have a string array called parts, and this will be s dot split on colons. And then the name is going to be parts at bucket 0. Number of chapters will be parts at bucket 1. And summary would be parts at bucket 2. Yeah, because this is an int. Yeah, so this guy will be integer. Parse in it, because it'll come in as a string here. All right, so now we have a new way of creating a Bible book using a string where we'll split it on the colon and set our 3 parts: the name, number of chapters, and summary. Yeah. Well, you don't have to have both, but I mean, we might want to have both in case we want to create a Bible book directly. But I mean, for the assignment, you're creating it all from the file, so you wouldn't need to have both of them. It knows which one you're calling, because this one's going to take 3 parameters. This one takes 1. Java will figure out which one you're doing based on how you're calling it. All right, so then inside of, so now we have a way of creating a Bible book by just giving it a string. So what I'll go ahead and do is I'll just get rid of these guys. And I'll go ahead and create a Bible book array called, let's call this guy books. And this is going to be a new Bible book array. And I have 3 of them in there. So I'll just hard code it as 3. And we'll go ahead and have our same input as long as input has next. I'm going to need to, I just happen to know I have the correct number of things inside of my book. So what I'm going to do is I'm going to keep track of a position, start that off at 0. So what I'll say is books at bucket pause is equal to a new Bible book created by input.next line. So that will generate the Bible book from the next line of my file, and we'll put it in books at position pause. We'll prove that it's working by saying books at position pause dot display. And then we need to make sure we increment pause so that it fills up the next thing in our array. So that should give us our Bible books read in from a file like that. All right, questions about that? Now, what if we didn't know how many things were in our file? I don't think input has a, well, we don't have to worry about whether it has a next or not. So what if I don't know how big to make this array? What if I wanted to use my file to go through and figure out how many Bible books will I be reading in so I can create the array the right size and then make the Bible book array? How would I go about doing that? So how do I figure out there's only 3 things in this, 3 lines in this file first? Go ahead. That while that you have ends up with policy equal to 3. Okay, so I could come up here, I could say while input dot has next and just say pause plus plus in here, right? The whole purpose of that while loop is to ultimately give me a number that I can create my array out of. Right? But the problem with this now is now I've burned through my entire scanner. So I've gone through, I've counted my number of lines. This is what this guy does. This counts the number of lines in the file. So I can create the right size array. So I keep track of the number of lines, then I set it equal to pause. In fact, maybe pause is the wrong thing here, because I'm probably going to want to use pause for this next one. So maybe I say int num lines starts off at 0, and then I say num lines plus plus in here, and then I create my array with num lines. Now from there, the next thing I want to do, now that I have the correct size array, is I want to go back through that file and read the stuff in to my array. Now the reality is that I believe this will work. We have to test it here, but I saw that there is a function in here called reset. Resetting a scanner discards all of its explicit state information which may have been changed. So it's possible that resetting this guy will let me go right back to the beginning of it and start reading from it again. If it doesn't do that, then we'll have to close it and reopen it. Not the end of the world, but let's just see if resetting it. So we are trying to put us at the beginning of the file so we can read in data. Nope, doesn't do it. So what we'll go ahead and do is we'll say input.close. We'll close it here. Then we'll reopen it, giving us a fresh version of that file, which is reopened at the beginning. I'm still running through it, right? It probably would be a problem. Let's just print out num lines here. Oh, why is it still running? We'll just say I did this as an exercise for the class. What didn't I do? This is an infinite loop right now, right? Yeah, it has a next one. What do? I just num lines plus plus. I don't actually read the next line. I just keep asking, is there a next line? Yep. So we probably want to go ahead and burn through that line. We don't need to put it anywhere, but we definitely want to make progress through our code. Let's go ahead and try the reset now. And let's see if that does actually get us where we want to be. Oh, thank you. We'll stop running right away that time, right? Okay. So let's make sure that we have the num lines is 3. So there's our 3. Reset did not work, so we'll go ahead and close it. And then reopen it. And there we have our name. So now we can have more things inside of our file if I want to copy these things and I don't know, paste them multiple times. Now we'll just get more Bible books in there because now it's reading in the number of things that are in my file first, setting my array to be the correct size. Then it's going to go through, I'm printing out the number of lines there. I don't need that in there. Then it'll close my file. Then we'll say reopen the file to put it back at the beginning. And read stuff in. All right, make some sense? All right, so let's go ahead and let's save this. I'll push this up there and then I'll create a new project. Actually, before I create a new project, I want to do some, what if I want to write to the file? So this is updated for homework 6. Is that what this homework assignment was? All right, so let me see if I've shown you writing to a file in here. Yeah, I really didn't, so we need to create a Printlwriter to write to it. In fact, let's just do that on another project. So we kind of set up for our searching sorting. So I'll just steal that line so we can easily create our file IO again. So I'm going to create a new Java project. And we're going to call this guy, I don't know what I'm going to call it. Writing files, something like that. I'll not create my module. I'll close all of these because we know how that gets me confused. And then we'll go ahead and create our class inside of source. Call this guy driver. Get our hello world program typed in, make sure this guy runs. Okay, so we have a working project now. Just so I don't forget, let's go ahead and create our repository. Yeah, actually, this would be a good example because I actually did it backwards. So actually, we'll want to do our repository there at the end because what I'll have to do is copy it. Actually, can I do it with, I think I can make this work. So if I say file, new repository, and we're going to call this guy writing files. I'm going to choose the local path, and rather than putting it in downloads, I think I need to put it into my Eclipse path, which is where? Eclipse workspace? Nope. So it's Dropbox Eclipse workspace. So I'll go to Dropbox, go to Eclipse workspace. Here's my writing files. Just do the whole folder there. So the local path to where that'll be is that writing files folder. I'll go ahead and create repository. I'm gonna have to work backwards from it because it's not inside the. Yeah, so you built it inside of that directory. So I actually needed to do it one level up. Life's just going to be better if I do this. I'll copy this. I wonder, can I close that project? Let's save this. And then I put bin and source inside of here. And I copy this guy. I go up one more level to my Eclipse workspace. I'm going to name this something else so I can paste this in there. Okay, so now that found that, let me make sure I can get it back in here. I'll import projects from folder, directory, Dropbox, Eclipse workspace, and I'll do writing files. Oh, existing projects into workspace. That's what I want. It doesn't seem to be it. Okay, so I resurrected it. Let me just say what I just did there. Probably the best thing to do is just don't forget to create your repository first, and then create your project afterwards inside the repository. But since I created my repository, or created my project first, then I went and created my repository. I had to move my project into the folder where my repository was, delete the project from Eclipse workspace, which does not actually get rid of the files associated with it, and then re-import the project into Eclipse by going into right-clicking and saying import project from folder or archive, and then finding it to bring it back in there. So now I have my working project again, but probably not the way you want to accomplish that. I would say just create your repository first and then put your Eclipse project inside of that repository. But in any case, now I can go ahead and just say initial commit. I'll commit to master. We'll go ahead and publish this. We'll call it writing files. I'm going to have this code not be private, and I'll publish it. So now it's up on GitHub. Okay, so what I'm going to do now is I'm going to go ahead and create a file to store some stuff, but we also want to be able to write some stuff to the file. So we want to be able to go both directions because we want our program to be able to read and write files. And I'm intending on doing the writing with Printlwriter, but I'll actually do a quick Google search to see if there's a more modern way of doing it. So let me create the file here first. So we'll create a file. We'll call this guy, and we'll put it in the source directory like it's defaulting to. We'll call this data.dat. Sounds good enough. Okay, and we'll start this guy off as the empty file because there's not going to be anything in it. Now, just so I don't forget, let me go ahead and just get my input file from this guy, just that line for scanner, so I don't have to remember that get property thing. All right, this guy's called data.dat. And we'll import scanner. Well, we'll throw our file not found exception, and we imported our scanner. So this guy should run now, but there's nothing in that file. So let me quickly do Java writing to files. I historically use a Printlwriter, which is the same thing as system.out. Let's just see if there's a more modern way of doing it. Yeah, Filewriter, which I'm guessing is a Printlwriter. So we'll say Java Filewriter. This goes back to what we learned in class more recently, is how to read documentation. So let's see, we have a Filewriter, which is an output stream writer. Does Printlwriter not exist anymore? Oh, Printlwriter is just a writer. Okay, whatever. So we're going to go ahead and create a Filewriter. Now, how do we create Filewriters? We create it with a, we can give it a file, or we can give it a string to the file name, but this is the file name, not the path. So we probably want to create this with a file object. So let's go ahead and click on File. Constructors for file, we have a path name. So that's similar to what we did for our scanner. So we're going to go ahead and create a file with our path name. So we're going to say file F is equal to new file. Our path name is, well, actually, we already have the guy here. Here's our file right here. I'll comment out my scanner for right now. We're not going to use it for right now, but we'll test it later. So I went ahead and created a instance of file called F. That's going to be my data.dat file. Then we want to create a file writer. So go back into the documentation here. I'll just hit the back arrow. Here's my file writer. We can create a file writer using a file. So I'll call this guy writer is equal to a new file writer built using my file that I just created. Now it's going to want me to import java.io file writer. So now I have my file writer. And this guy also is going to have a exception it can throw. If, what is this one? It's a IO exception. So if you try to write to the file and something bad happens, so I can actually say throw the declaration. It'll add another, actually it's allowing me to throw, I think I can throw multiple things. So can I say IO exception? I think that's allowed, isn't it? Well, I can only throw one type, and I'm going to throw anything that's an IO exception, which also is a file not found exception. Or you can really cheat and just say throw exception. So anything that's bad, throw it. Again, we talked about this before. This isn't necessarily great programming practice, but we should probably surround this by a try and catch and handle any sort of errors that happen if we're trying to write to our file. But since we don't intend to handle those right now, we're just going to assume it works. We'll keep our code looking clean enough and just throw all exceptions for right now. All right, so now I have a instance of something called writer, or of something called a Filewriter called writer. Now let's go see what this dude can do. So I've created one of these guys. Now we have a whole bunch of methods that are that we inherited from our parents. That's actually interesting. So this guy he inherited from an output stream writer the idea of this thing called a write. So I can write a string. Yeah, so I just write a string. And that'll let me do it. Good enough. All right, so we'll go ahead and we'll just say we'll do a for loop for int I is equal to 0, I is less than 10, I plus plus. And we'll go ahead and say writer dot write. And we'll go ahead and just give ourselves the string version of I. So this should write a 0, a 1, a 2, a 3, a 4. All right, we went ahead and ran that. Now notice there's nothing in our data.dat. Just before I confirm why, writer.close. Make sure this puts something in there. Now we have stuff in there. So what happens is when we do file IO, what ends up happening? When we open a file, so right here, I'm creating a file, I'm opening a file from my computer's hard drive, right? And it's putting it into my computer's memory. Now I have this ability through this file writer to write stuff to my file. But where I'm actually writing it is I'm writing it to memory, not to the hard drive. It's not until I actually close that file do any changes that I wrote actually get written to the hard drive. So just to show this again, if I go in here and I delete everything from this file and save it, notice I'm opening the file, I'm creating my writer, I'm going through 0 to 9, and I'm writing a bunch of stuff to that file, but I'm not actually closing that file. So those things that I wrote only got written to memory. They never actually got put back onto the hard drive. That make sense? So rule of thumb is make sure you, once you're done using a file, you close the file. All right, and I'll go ahead and tack onto this a \n so it kicks it down to the next line. So now I have my numbers in there all on one line, or all on different lines rather. Okay, no big deal. Pretty simple file IO, writing to a file thing. I think I used to use something called a print writer, which is, I looked it up a minute ago, didn't I? That's just a writer, so I would have had to write one character at a time. Whatever. Okay, but again, this is that ability to be able to use the built-in documentation now that we understand the difference between class methods and instance methods and those things. Okay, so we now can write to a file. Let's go ahead and let's fill up a file with a bunch of random numbers. Random numbers that we're going to be operating with moving forward for doing some searching and sorting and that kind of stuff. Okay. So what I'm going to do is let's create a random R is equal to a new random. Have I created random numbers in here yet? Have we done a random object? Oh, just, okay. All right, and we'll go ahead and just write numbers. So we'll put 10 numbers in here, and these guys will be numbers between let's see, 0 and 10,000. That's what we'll put in there. And I'll go ahead and dump the contents of this. Now, what we probably want to do is I'm going to actually move a lot of this code into a method that we'll write to the file, because once we write to it once, we're probably not going to want to keep writing to our file over and over again. I want to use that tool once, get our file filled up, and then we're going to start doing operations on that. So let me just quickly write a static method here. So we'll say fill file with random data. Let's call it random numbers. This will take in how many. It's going to return nothing, so it'll be a void. I'll bring my instance of random in here. And I'll go to my how many. All right, so now notice that our write is not happy again. So this guy still throws an exception. He throws an IO exception. Now remember before I said, well, I threw the exception here, but now this method throws an exception. So I could pass the buck. I could just say throws exception. I'm going to spell it better by just copying it. So I can say throws exception there, but if I remove the throws clause from up here, it's going to be unhappy with me again in a second here. When I say driver dot fill file with, I'll just say 20 things. Notice when I hover over this, it says unhandled exception type exception. So even though this line right here throws an exception and I decided to just go ahead and pass the buck, who did I pass the buck to? I passed it to my own main method. Make sense? So now I can go ahead and I can pass the buck again and just let the Java virtual machine handle it. But generally speaking, a good rule of thumb would be if something throws an exception, handle it locally. Only pass the buck if you have to, or in this case, we're not really focusing on exception handling right now. So we are throwing it so that we don't have a whole bunch of try-catch stuff kind of messing up our code. We want to focus on the logic that we're writing. Kind of make sense? So I'm kind of showing you a less than ideal programming practice here by always throwing the exceptions, because I don't intend to deal with them right now anyways, because we're not actually focusing on exceptions right now. I'm just making the error go away. Eventually, we will talk about exceptions in detail. But now all the red squigglies are gone because this guy throws an exception, which we then just pass the buck. This guy throws an exception because we passed the buck, and I just went ahead and passed it on. No harm, no foul. All right, so this will fill up with a certain number of things. So I'm going to say, give me 20 random numbers. So notice here that I have 20 random numbers in here. I'll go ahead and run this again. I'll make this 50. Now I have 50 random numbers in here. Why don't I have 70? I already had 20. Actually, why don't I have 80? I had 10, then I added 20 more. Why was it 20 instead of 30? Every single time I open up a file, and I write to it, when I open that file, I'm opening it up to overwrite the file, unless I specifically open it up to append. Okay, and let's see with file. It's probably going to be the file, but when I open it, I can say I want to append to this guy. It is not at the file level. Let's see if it's at the writer level. Ah, so here's a version of Filewriter that takes in, so look at the constructor summary here. We use this constructor that takes in just the file. Here's a constructor that takes in a file as well as a true or false, whether or not you want to append to the file. So just to see that version of it, so see how we have multiple, this goes back to your question before. How does it know which constructor you're calling? Well, if I pass a guy just a file, it's going to call this one. If I pass it a file and a Boolean, it's going to call this one.
So if you pass it a file and it's false, that would be the same as you call it just a file?
Correct. Yeah, so he's saying, what if I did this? So if I created my Filewriter and I passed it the file and false, it's going to keep doing the thing it's doing right now, where it just overwrites the file. But if I say true here, now I'm saying append to that file. So this file currently has, what, 50 things in it? I'll put another 100 in there. So now we'll have 150 things in there. All right, see the distinction there? So not the end of the world for us. It's going to be whatever the right tool for the job is for you. Just remember that when you open a file, you are opening it for either reading or writing, and that comes with the consequence, or I'm sorry, you're either opening it for overwriting or appending, and that comes with the consequence of saying, do I want to replace all the stuff that's in there, or do I want to add to the stuff that's in there? A lot of times you might say that when if you're trying to store stuff locally in a file to maintain the state of our program from the last time we ran it, maybe we do usually want to just completely overwrite the file to kind of give a snapshot of where we left off, that type of thing. But if you're having some sort of ongoing records of things and stuff like that, like if we pretend databases don't exist and you want to have your own username authentication thing, we create a new user, we probably want to add the new user to our list of users, not overwrite our list of users every single time. So ultimately it comes down to what's the right tool for the job. So for us right now, I'll go ahead and leave a false in here. So this, I'll put a little comment. So open, there's like writes, call this overwrites. The file. And I'll go ahead and give myself just 50 random numbers. And now I have 50 numbers in there. And I'm going to say, okay, I'm good. So I'll comment this out or just not use it again right now, just delete it. I've already filled up my file, rather than me going in and typing in 50 numbers, I have 50 random numbers now I can play with, sitting in my file. All right. So now we say we might want to do some things with those numbers. Well, we might want to have a function that reads the elements of our file into an array, for example. All right. Now we're going to cheat a little bit here, because one thing we ran into in the next class, CSC250, we're going to be talking about writing our own linked lists, so elastic data structures. What we saw earlier in the day today was if we wanted to kind of know how many elements we needed to store, what did we have to do? We had to go in and kind of run through the file once, count how many rows there were, then reopen the file, go through it again and fill it up. We had to make kind of 2 passes. It would be nice if we had a collection that allows us to just add stuff to it whenever we wanted to add stuff to it, kind of like lists work in Python. So arrays in Java are a little bit less, are a little bit more primitive. So we can't just arbitrarily add to them. But we do have this thing called an array list, which I'll go ahead and add to the notes, and then we'll go to the documentation. It might be in one of my things further on, but let's just look at it now, since I think it'll make our life friendlier right now. And now that we know how to read the documentation, we're allowed to, right? All right, so I'll just do a quick search here. Java ArrayList, pretty sure that's what it's called. All right, so notice here that an array list is this, like, it's an abstract collection, which is an abstract list, which is an array list, and it has these little brackety things after it. And I'll talk about that here in a few minutes. But in any case, when we create an array list, you can say I'm going to create it with an initial capacity, or you can just say I'm going to create a blank one. For right now, we're just creating blank ones. Creating it with initial capacity kind of adds some performance, because the way array lists work under the hood is they work with normal Java arrays and just keep resizing them. So what you can do is you can say, I'm going to go ahead and I know I'm going to have to hold 1,000 things at least. You can build it with enough capacity for 1,000 things, and it'll make your program a little faster, right? We don't care. We like to beat up on computers, so it's fine. We'll just say it's an array list. You do your thing. I'm going to fill it with whatever we want, right? All right. So here's the constructor for an array list. Easy peasy. Doesn't take any inputs. So let's go ahead and create one of those guys. So we'll just do some file IO in here, and then we'll move it into a function. So I'll go ahead and create a array list called my numbers. And this will be a new array list with no parameters. All right. And it's going to want me, I think ArrayList is in java.util. If I go back here, we scroll up to the top. Yeah, so we see this guy lives inside of java.util. So a lot of our utilities live inside of java.util. A lot of our input-output stuff lives inside of java.io. Just kind of weird how scanner lives in java.util, but whatever. They live somewhere. This is a library that it's living in. So we can hover over this and we'll say, we'll go ahead and import java.util.ArrayList. So now we have access to that dude. Go ahead. It's not a slower thing, it's a file size thing. So if she's saying, what if you just did this? What if you said import java.util.star, which says, give me everything that's in the util, even though we might only use 3 things, right? Realistically, it probably won't make any difference to us. But what you will end up with is when this gets compiled, it's going to bring all of those things from util into your compiled bytecode, even though you're only using 3 of them. So your ultimate executable will be a larger file. Maybe we don't care, but if you use Eclipse to handle it for you, you'll only import what you need to import. And then notice here that it underlines the things you're currently not using. Like I'm not using file not found exceptions. I'm not using IO exceptions because I actually just use the generic exception. It's like I'm like really lazy there. It's like I don't even care what kind of exception it is. I just don't want to deal with it. So I'm just throwing anything that fits the thing of exception. But historically, what you're saying is that you'll see a lot of code examples where they just say, I'm going to use some stuff from util, so I'll just import everything from util. Not the end of the world. Just give you a little bit bigger file size. Okay, so I have my array list. Now, array list, let's go look at some of the abilities. 35, right? 1235 is when we get out? Oh, good. Perfect. Oh, it's 235. It's 50. My next class gets out at 225. Gotcha. I keep going 10 minutes over in my next class. That's the one I keep going along on. So, what was I doing? Oh, we're looking at the documentation for this. So these are how we build them, these constructors. This is what we look at when we say, how do I make one of these guys? So we just made an array list using the default constructor. Give me an array, empty array list. I don't care how you have to handle it. here's our methods. So we can add things to our array list. That's probably what we're going to want to do, is add some values to this guy. Maybe we're going to add strings. Just keep working with strings. Strings are really very malleable inside of Java. We could also look in here. We can get a value from a certain index. That's like, you know, get me bucket 4. You know, we can use get to get that. We can ask about the index of something, similar to how strings work. We can ask if it's empty. We can get the last index of something. We can remove elements from it. So lots of stuff. We can ask its size. So size of an array list is like its length. We'll explore a couple of these things here in a minute. Okay, so come back out here. So what I want to do is I want to read in from my input file and put all those things into my array list so I can now conveniently work with them inside my program. Okay? So we'll say while input dot has next. So as long as there's more things in my file in this case, what do I want to do? I want to say my numbers dot add. Now notice here, when I say dot add, the thing it's asking me, well, the thing it's expecting me to add is a generic object. Now I'm going to be reading in strings, right? Even though we might want to work with them as numbers, let's just get them as strings for right now, okay? So I'm going to be reading in strings, but this guy, as he's currently built, is built to hold generic objects. And that's kind of how lists work in Python, where with a list in Python, I can put 2 strings and an int in there because it can hold any sort of object type, right? Right now, the same thing's true with my array list here. But realistically, I know that I'm going to put strings in there. But just to kind of go down this path, we're going to leave it the way it is right now. So I'm going to add something. What am I going to add? I'm going to add input dot next line, which is a string. And this guy's okay with that. But why is it okay with that? Add was expecting me to give it an object. I gave it a string. Is a string an object? Yes, it is. That's how the inheritance model works. So if I go and I look up Java string class, we scroll up to the top here, we see that string inherits from object. Make sense? With nothing in between. So you can see how primitive strings are to the Java language. They're barely off the generic object thing. And that's why they're treated like primitives in Java. Go ahead.
So when you look at things in the array list, will it as a string?
No, it'll come out as an object, but we're going to fix it. Yeah, I'm going to take you down the inconvenient path and then swing back. Strings will actually work out okay because of something else, but we're gonna pretend like they don't work out okay and do this the right way. All right, so we're gonna have my numbers. We're gonna add a string, which is an object, so we're okay. Okay, so now I have my whole collection. If I run this, we'll see that actually I didn't close my file, but I'll go ahead and close my array list. It's okay. Technically, it's okay if you don't close it. If you're reading from it, because we're just abandoning it in memory, so it's not, you're leaving a mess behind. But because you didn't change it, you're not worried about it not getting written back to disk. Okay, so we'll close it. We write it all in. So now we'll go ahead and we're going to go through all the elements in our array list. So we'll say for int I is equal to 0, I is less than my numbers dot size. So dot size is how we get the number of elements in an array list. I plus plus. And then we'll go ahead and we'll write system.out.println. And we'll say my numbers dot get. And I give it an index. And I'm going to say get index I. But we back up here and I say dot get. Notice what get returns. It gives me an object, not a string. I know I only put strings in there, but because I built this guy to take objects, I put it in as a string. A string is an object, so that's legal. But when it comes out, as far as what Java is able to tell me, is it's saying, look, here's the object I found at that index. With Python, this is okay. Because Python, it has a type inference engine to figure out what kind of type you're dealing with as you're using it. Java is a strongly typed language. So when I have something as an object, Java is going to say, look, as far as I know, the only thing this guy knows how to do is the stuff that objects know how to do. Okay, I'm going to kind of show you that here as an example. So I'll go ahead and get bucket I, and we're going to print that out. All right, and it's going to be fine with this, but I'll show you why it's going to be fine with it in a minute. We're going to go back and look at the documentation and see why it's fine with this. So what did I do here? What's this guy complaining about? Oh, yeah, it's complaining about the thing I'm about to teach you about. All right, so I'm filling up my array list from my file. I'm closing the file. Then I'm going to prove that I filled it up by spinning through my array list, printing each element out. All right, so there's all my elements that I read in from the file into an array list and then printed them from the array list. Everybody's cool with that? Okay, so now the question is why did this work? I'm going to write something here. I'm going to say .toString. We're used to using this system.out.println thing for printing stuff to the screen, right? Now, what are some things we've printed to the screen before? We've printed out integers, we've printed out strings, we've printed out doubles, we've printed out chars, all sorts of different things. Println is not this single magical function that knows how to print everything. When we go into the documentation, we'll actually see that there's a whole bunch of versions of Println. Okay, so I'll do Java system class, because that's how we know how to get to it, right? System, name of a class probably, because it starts with a capital letter. So here's the Java system class. We'll see that this guy has a field summary, and one of those fields is called out. It's a static field. That means it's owned by the class, hence system.out. Make sense? So I'll go ahead and click on a print stream. Let's see what out is. He's one of these guys. So print streams, let's get down to the printlns, have a whole bunch of versions of Println. We have one that takes nothing. It just terminates the line and goes down to the next line. It takes a Boolean, a char array, a double, a float, an int, a long, a string. It also has something that takes in an object. And this is the one that we're looking at right now. Because what did I extract from my array list? I extracted a generic object. So what Println does when I create an object is it will call that object's toString method. That's what it actually is accomplishing. And if I click on object here, you'll see that objects, I mean, these guys are the bare bones minimum that you need for an object in Java. You'll see that they have a toString method, which gives a string representation for this object. And you might assume that the string representation for a generic object might look like a crazy memory address. Let's go look at that real quick. So just as an example, I'll just create a new, we'll call this guy test object. And I actually won't put anything in there. No fields, no constructors. By default, he gets a no argument constructor that does nothing. So this guy is a waste of time object that still is technically an object. I'll go and create a instance of him. So I'll say test object, TO is equal to a new test object, and I'll call the no argument constructor. That is the constructor that takes no parameters that I did not write in here, but Java gives to me so that this syntax will work. And then what I'll do is I'll say system.out.println to.toString. So the toString method is something that all objects get. And I'll go ahead and print this. You'll see crazy memory address. So there's memory addressy thing. I'll also show you this. If I take the .toString off, you'll see I still get that crazy memory address. And why is that? This kind of goes back to the same thing you asked about constructors. When I call a method, it calls the version of that method that is in line with the parameter or parameters I gave it. We just saw here that Println, there's a whole bunch of versions of Println. Which class am I now? I'm in object. Whole bunch of versions of Println. What am I passing it? I'm passing it an instance of my test object. Now, first of all, the Println method, this was written before class started today, right? Significantly so. So they didn't know about our test object that we just invented. So we're not surprised that we don't find one of these guys that just happens to know how to print a test object. Now, what am I passing? Am I passing in a Boolean? No. Am I passing in a char? No. Am I passing in a char array? No. Am I passing in a double? No. A float? No. An it? No. A long? No. A string? No. I'm passing in a test object, which at its heart is an object. And what does the version of Println do for objects? It calls that object's toString method. Why does it know it can do that? Because every single object gets a toString method. How do we know? Because it's included in java.lang.object. They all get a toString method. That makes sense? So that means in my code right now, I'm getting crazy memory address because this is what the default toString method does for objects. Now, if I want to change that, I can come in here and I can say, well, you know what? I'm going to say public string toString, and I'll just return woot. That's what a test object's toString method actually should do. He should return woot. And now when I run this, we get a woot. So we're proving it's calling the toString method. I just redefined that toString method to have something a little bit more appropriate for our test object. That makes sense? So our version of Println that knows how to print an object is kind of a catch-all. It says, look, here's all the primitive types that I know how to print those. I'll even let you give me a char array, because that kind of might make sense. You might want to conveniently print char arrays. Strings, yeah, no problem. I'll have the strings for you. But anything else, if you want it to be something special, you got to write your own toString method. Otherwise, I'll call the generic toString method, and you'll get that weird memory addressy thing. Make sense? All right. So this is good and bad in that it makes all objects compatible with Println. But if you don't do something special, you'll get the weird memory addressy looking things. Not a problem. Kind of reminds us those things are probably passed by address, right? Okay. But still, as we are taking stuff out of our array list here, it did come out as an object rather than as a string. It doesn't break it for us in this case because strings do overwrite the toString to have their own version of toString that shows the contents of the string rather than crazy memory address. So in this particular case, it happens to not make our life harder. But the intended use for an array list is with something called, what is the name of these guys? Generics. They're called generics. We add this to the, no. This guy uses generics to allow us to create collections of a specific type. So when I create my array list, I can say, you know what? I actually want this to be an array list of strings. I want this to be an array list of strings. So when you build my array list, give me an array list of strings. So notice here now, when I do ArrayList.get, notice it now gives me a string, not an object. Now I could have always converted it back to a string. So, I'll just go ahead and pretend like it still gave me an object here. If I want that guy as a string, I can typecast it to a string in front of it like that. And then put the whole thing in parentheses and say, okay, now I got a string. I can call string methods on this dude. But let me show that to you. So if I take the string thing out here, we know that this guy is a string. But right now, because of the way I built my array list, Java is only comfortable with guaranteeing us it's an object. So if I say get at bucket I and I know it's a string, I want to be able to call the length method on a string. Right? Java doesn't think I can, because it can't promise me that's a string. It knows it's an object. But if I go and look at the documentation for objects, I will not find a length method. Make sense? Now, I can fix that by doing this. I can say, okay, well, you're actually a string. So since I typecasted you to a string and then put this whole thing in parentheses, now Java knows that, okay, trust me, it's a string. I can now call the length method. Alternatively, I can say, you're a string. And now this guy doesn't need to be typecast because he comes out as the right kind of animal. Go ahead.
When you remove the typecasting thing and not the thing in the ArrayList part, that wasn't actually changing the object from an object to a string size the string.
Well, no, it was storing it as a string in the array list.
It was?
When I did the typecasting. Yeah, no, it doesn't change it. It just takes whatever came out of there and converts it into what I'm telling Java, trust me. Trust me, it's a string. I might be wrong, but I'm telling Java, don't scream at me about this. I know what I'm doing. But the appropriate way of doing this is create your collections with the type that you know you're collecting. That way you don't need to do typecasting stuff. And we see this does look more convenient than those parentheses and things. If you're always going to work with them as strings, why should you have to typecast them to strings every single time? Right? Generics are your friend. All right, so now we have this collection of stuff here. Let me jump forward. We'll talk about this big O notation maybe next time. For our linear search, this is something where we're searching for a value. We literally start at bucket 0 and we go all the way to the end. We're just going one bucket at a time. So, here's an example of what linear search is. So what we want to do is, for our homework, we want to expand our last assignment that reads in the Bible books from a file and allow the user to search through the summary of the books for a given keyword. So, for example, if, I don't know, let's say you are looking for the first Bible book that it finds that has in the summary, Jesus. So if I have my books, and I do a, you know, and I search for Jesus, maybe it spits out the Bible book that is Matthew, because chances are Jesus is going to be in the summary of Matthew, and it's going to be the first book in the New Testament. So, you know, the idea is that we have a collection of Bible books, put them into an array list. So store the books in an array list of Bible books using generics. Then allow the user to search the summaries and return the first Bible book found that has a certain keyword in the summary. So for example, if we were to search for Jesus, maybe it would give us the Bible book Matthew. And we're going to be doing this using a linear search, which is nothing fancy. You literally go through your array list from bucket 0 to bucket 1 to bucket 2, checking the summary in each one for the word Jesus in there. Okay? Now you know how to use the documentation. So a hint for this guy will be Java string class. And you've seen the index of guy before. Notice there's 2 versions of index of, actually more than 2. Here's a version of index of that takes a string. So for instance, if I have this big long sentence, my summary, and I say that dot index of Jesus, it will tell me the index in there where it's first found, or -1 if it's not there. So I can effectively search a string, you know, that has 500 words in it, to see whether it contains a certain keyword by looking for the index of that keyword in there and making sure it's not a -1. If it is a -1, it wasn't found, I can go check the next Bible book. If it was a -1, if it's something other than a -1, I found it. I can return this Bible book as being the first one I bumped into that has that keyword. Yeah.
So would that return the index that it returns? Would that be like
The index within the string.
the index of the word?
The beginning of the word. Yeah, the index in the string of the beginning of the word. Yeah. But in this case, you're just saying, find me the first Bible book that has this keyword in its summary. So you'll check Bible book 0, see if it has the keyword in the summary. Bible book 1, Bible book 2. And as soon as I find one of those that matches it, return it. That makes sense? All right, so I'll push this current code up to GitHub. I'll put the assignment up, and I'll see everybody on Tuesday.
Bye.
What?
Bye.
There is a linear search stance. I think you should probably then put the linear search stance up on Slack.
Yeah, I did that.
Okay, good.
It is. Oh.
So if you want to see how linear search works, check it's the simplest search. Was there a question online?
Yeah. I was having a problem with the heck is it?